Thank you, everyone. So, yes, just very briefly, for those who haven't seen me yet, so I'm part of the Open Technology Group at IBM, which means that I'm an open source and open standards specialist. I spend most of my career working on web standards, mostly involved with the W3C, but for the last 3 years, I've been pretty much full-time on blockchain, especially with Hyperledger. And so I am a contributor to Hyperledger Fabric, and I am an elected member on the steering committee, which is responsible for overseeing the technical direction of the project. It is important to know that Hyperledger is not a software. It's really an organization that hosts several projects that are essentially, the idea was to create a venue for the industry to be able to get together and create, develop blockchain-related technology in an open source framework, with some, common rules, and such as all the Hyperledger software is available with an Apache software license, which is business friendly. And the focus is away from cryptocurrencies and really about blockchain for the enterprise. So, I'm most known, and I gave earlier today a session, I gave a talk about Hyperledger Fabric, and this is what Hyperledger is mostly known for, and I hear a lot of people say, oh, we use Hyperledger in our solution. I'm like, how do you use a consortium? And so usually that means they mean Hyperledger Fabric. But as I said, there are actually 5 different frameworks that can be used independently from one another, and so Fabric is only one of them. There are others. And I'm actually going to talk about another one here, which is called Hyperledger Indy. Hyperledger Indy is a blockchain framework and a set of tools and libraries that is really purposefully designed for self-sovereign identity, which is what I want to talk about. The presentation is not going to be very technical because it's still a fairly new concept. I'm sure some of you are familiar with the concept, but bear with me. So I've been working on blockchain, as I said, for 3 years. I work on a lot of different use cases, and supply chain, as I call it, is the poster child of blockchain. And at the same time, I think self-sovereign identity, even though at the end of the day, the blockchain part arguably plays a fairly minor role, I think is one of the most interesting, exciting application of blockchain. So first, let me give you a little bit of background. When the internet was created, it didn't have any identity management system built into it, right? And so what we've seen is, with the development of the internet and then the web, we've seen the development of what we call centralized identities. These are essentially your user ID password that you use on every website to connect. It's a pain, we all know this. I don't need to explain to you. Every website has its own rules about what is a good password, what is acceptable, expirations are different, and the likes. So there are people who said, hey, we can switch to a different model, which we call federated identity management, where you have companies like Google, Facebook, LinkedIn, and the list goes on, who says, don't worry about creating a new user ID password to log to this website. You can just use our user ID. Of course, it's convenient, but the cost is you actually get traced everywhere you go, right? And so that's why they do it, and they do it for free because they get to see everything you do, or at least, they know where you're connecting, etc. So then we saw a different wave, which created this notion of user-centric identity. And so I'm referring to things like OpenID, where the idea is, well, instead of relying on a specific service to create an ID for you, you should be able to create your own identity and then carry that over from one service to another. The problem is, with things like OpenID, you still depend on some service that actually manages your identity for you that is centralized. And at the end of the day, there are also web IDs, for instance, another example, where you create your domain. You can even create your own domain name. The problem is, arguably, DNS is not decentralized, it is centralized. It's a hierarchical system, and there is ICANN at the top that controls the whole system, and it's under the governance of US. And even though several years ago Europe tried to, wrestle with the US to say ICANN should be international, they managed to keep it. And so fundamentally, you're always at the mercy of your service provider, to keep honoring the requests that come associated with your domain name. So we are now moving into this new era of self-sovereign identity, where you will become the owner of your identity and at least have the full control of it. So this is what really I want to talk about. So first of all, let's step back and say, okay, what would we ideally have? What would be the key elements of a system where, we have full trust in digital identity management and control? So I may not go through all the details one by one, but there are some key important aspects. Of course, being the authority over having the control of your identity is a big one. Another important aspect is being able to decide what you disclose. Because today, as you know, when you connect, you disclose information, they collect information, you don't know who collects what, you have no visibility. It should be decentralized, distributed. And in fact, it would be ideal to have a system that doesn't just serve the purpose of individuals, citizens, but actually also work for organization and even things, because in the Internet of Things, everything needs to be identified. It needs to be open and flexible, interoperable, portable. Viable and sustainable is an interesting one, because there is always, at the end of the day, some economic aspect that come into play. And I'll talk a little more about this later on. So let's look at some of the benefits if we had a system like this, right? So for individuals, it means that we would have more control, obviously. We would be able to control what gets disclosed and to whom, so greater privacy. And things could become much simpler to do, such as, applying for a loan at your bank could be much easier. Even applying for a job at a company. There's always a lot of paperwork you have being asked to gather and provide, and then on the other side, organizations have a lot of work to do to verify all this paperwork and file it and whatnot. And there are regulations that they need to comply. At the same time, governments are kind of stuck in between, and they're trying to improve, services provided to their citizens and live in this new world in which we are. So what's interesting is, in this kind of system, and quite frankly, that's a feature, I think, of all the blockchain solutions, there's really not many people who lose in those systems. There is actually a lot more to gain than to lose, and for everybody, which is, I think, key to the success, and this is why I'm so optimistic about the future of this kind of system. So the kind of use cases, I touched on this aspect. Know your customer is some regulations today. Organization cannot just transact with you without knowing who you are. They have, by law, the duty to figure out who you are. So you can't just open a bank account anonymously. And if you transfer money from one country to another, they want to know where that money comes from. As I was talking about, government identity services is a big one. In Europe especially, there's a lot of work that has been done, and there is work that was done at the government level, at the national level, and many governments have made quite a bit of progress in providing electronic identity services. And now there's a European effort, and I don't know if you guys are familiar with the EIDS, but so there's a framework so that you would be able to connect, even if when you're not at home, in your own home country, if you're another European country and you have, like, say, I'm in Germany, I have a French ID, and I could go to an agency and they would still be able to verify my identity. And then identity verification network across industries, that's an obvious one. Everybody has to verify who they are talking to. And for those who were there, we've talked about Hyperledger Fabric. and permission network in general rely on access control of identity, which relies on identity. So there's actually a strong connection there as we move into this kind of system where we need to control access. We're going to have an efficient way of dealing with identity as well. So this brings me to Indy, Hyperledger Indy. That's the solution that solves all these problems that I was just talking about. And so it actually does. So I'm going to talk a little bit more about what's behind it. So Hyperledger Indy, as I said, is the project. It's a purpose-built, decentralized identity framework. It's based on blockchain. It's not just a blockchain. So there's actually a piece of blockchain with a network which is called Plenum. But there's a set of libraries and tools because you're going to see, I'm going to take you through a scenario, and it requires quite a bit of tooling as well. You're going to have this notion of digital wallets to store credentials. And so, Hyperledger Indy covers some of these aspects. One important aspect that I want to highlight before I go any further is what do we talk about when we talk about identity to start with? So in my story initially, I talked about user ID password because that's an obvious one. But here, what we are talking about is much broader than that. Because if you think about your identity today, your identity has many different facets and attributes. From the day you were born, you were given a name, you have certain attributes, maybe your gender, maybe you have like a place of birth, a date of birth. All of this becomes part of your identity. And from then on, throughout the course of your life, you're going to acquire more of attributes. So you're going to go to university, you're going to graduate, you'll get some diploma, you get a driver's license, maybe you become a pilot, you have a pilot license, and so on, right? You become you're an employee, you become an employee, there's a credential associated to the fact that you're employed, and maybe you make a certain amount of money. All these pieces become part of your identity. The problem is, today, every one of these pieces are not under your control. They're under the control of some organization, some government agencies, or some company. And that's fundamentally the problem we're trying to solve. Independent identity means that you become in control of all of that, okay? So, let's talk through a scenario now about how this whole system functions. You'll see it's actually not that complicated. So in this scenario, we start with the university where we have a person who goes to the university. Then when they graduate, so in this case, she graduates from medical school, and so the person becomes a doctor. The university is going to issue a diploma in the form of a verifiable claim or credential. This is information that can be stored by the user, okay, which represent the diploma, and I'll get more into what's in it later. At the same time the university does that, it's going to store on a public ledger. In this case, we use Sovrin. Sovrin is a non-profit organization that runs an instance of Indy, okay? And they're going to store on this ledger the cryptographic material necessary to verify the validity of the claim that was given to the person. What this allows is when the person then goes on to look for a job, they apply for a job at a hospital, they are going to say, hey, I'm a doctor. Well, and here's my credential. Now, the hospital is going to want to verify if that's true. How do they do it? As part of this credential, there's a unique identifier that actually points to the record on the ledger where the cryptographic material to verify that credential has been stored by the university. It will retrieve this cryptographic material and be able to verify the credential. This is all cryptographic. It's not that complicated. Essentially, you know, the university has signed with a private key the verifiable claims, and the public key is stored on the ledger. So the hospital can put the two together, verify that it actually was signed by that key. There is a little bit more information because you also need to know what has been signed. And so in that information on the chain, there's also some schema information. And you need some standard there to know what it is. Because, you know, if it's just a driver's license that you're presenting, claiming that it's a diploma of medicine, the hospital need to figure this out, right? So it's not enough to be able to find a signature that says, yet it is a valid credential. You also need to know what the nature of the credential is. What's interesting is the verification. We call it blind verification because the issuer is never contacted to verify this. What that means is that it means there is greater privacy for the holder of the credential. In this case, the person may not matter so much, may not care so much. The university gets interrogated every time they apply for a job, but fundamentally, it's an intrusion on privacy. And there is another aspect, which means that if the university were to disappear, may not be a good sign for the value of the diploma, but that put aside, if the university were to disappear, the verification can still be done because the credential is still in the holders, the digital wallet, and the cryptographic material to verify it is still on the ledger. So the beauty of this system is that you can repeat that as much as you want. So the person can apply to many different hospitals, and the same process will apply. And the same process will apply with as many issuers of credentials as you want. So for instance, let's say the person has got a job now at a hospital. The hospital with the employer can issue a credential that states the person is an employee. And maybe this credential actually has some information about the income or the income level. Now the person is going to be able to use that credential to apply for a loan at a bank. And in a similar way, the bank will be able to verify that this credential is actually valid. So you see how this is going. What's interesting is that this can be combined. So in the case of, a bank loan, for instance, it's likely that the bank would want to verify also your national ID at the same time. And so those things can be combined. So the system is designed so that you can have complex queries and complex claims. What's interesting is that the person is in control of what gets disclosed and to whom. That's a very, very important aspect. Because if we don't have that, well, we have missed some of the target. So, so there's more to this. Because, in fact, if you think about it, today you have a national ID. It has all sorts of information. Typically, it has your name, your birth date, and your address, that kind of information. You go to a bar and they want to verify you're over 18 and you show your card. In showing them your card, you actually reveal a lot more information that's pertinent to the transaction. They should only have access to your date of birth, or maybe not even that much. They should have a way to verify you're over 18. That's the only thing that is required by law, right? So the system is going to be able to allow you to do this kind of checks. So we have real-time credentials verification with that direct connection. Again, that's a very important aspect. The issuers are not involved in the verification process whatsoever. We also have a mechanism to revoke, because it's important to be able to revoke credentials. Say, I talked about your driver's license. Obviously, the government should be able to revoke your driver's license if you're such a bad driver. You don't deserve to drive anymore, right? As I showed, we have also, they can be combined, and more interestingly, and this actually uses zero knowledge proof. So I don't know if you guys are familiar with zero knowledge proof. It's this cryptographic technique that allows to verify some information without ever having access to that very information. And you can do derive information verification. So in the example that I was talking about earlier, where we want to verify the age of a person, with the zero knowledge proof, we can verify that you're over 18 without ever disclosing the birth date, even though the only credential that was actually signed by the issuer, in this case probably your government, is actually your birth date. Don't ask me how it's done, because to me, quite frankly, it's a bit black magic. But you know, these techniques have existed actually for a long time. What is new is that the techniques have evolved in such a way that now they can become practical. So I asked some of my colleagues who are experts in the matter, and the answer is like, because there's a question of performance. Essentially, zero knowledge proof was, has existed for a long time, but before it was just not practical because it would take so long to do the verification, it was useless. But as I said, with the new techniques, now they can do a verification of that kind, like the over 18, in less than a second, which makes it practical. And Hyperledger Fabric actually has a lot of features now that leverage zero knowledge proof for identity verification in somewhat of a similar way, where we can verify attributes of the users without revealing the actual identity. What's interesting is there's the privacy respecting, and it comes in many different ways. So when you do these kind of transactions, it's important to realize that all the credentials, they don't share the same ID. So just because you have disclosed some credential, doesn't mean now you have revealed your ID to the person who is actually verifying, and that they can find all the information that relates to you. It's a very important aspect. And I've talked earlier in the previous talk about Bitcoin and its total failure in preserving privacy. And Ingo mentioned that too. There's a lot to be said about the lack of privacy on blockchain networks today, especially the public ones. But even in the private one, in like Hyperledger Fabric, we keep adding features to provide more and more privacy, because even within a permission network, people want privacy of different levels. So this system actually has anti-correlation features, which means that just because you have a bunch of transactions and you're transacting a bunch of different credentials that all relate to you, and that you're actually transacting with different parties over time, the parties will not be able to recognize two different credentials as belonging to you. And again, the selective disclosure is an important aspect in terms of, giving you the control over what gets disclosed. So let's talk a little bit about what is written to the ledger, because that's a very important part. And I'm also part of the EU Blockchain Observatory, which is a study group that is issuing a bunch of reports for the European Commission. And we had a whole study, and there's a on GDPR and blockchain. And there's a report that was published, I think last month we published it, and I invite you to look it up. It's very interesting, because there's a lot of tension between GDPR and blockchain. And the biggest mistake that people can make is to put personal data on a chain, because it's there and there's just no way to remove it. And people who say, oh, but we encrypt it, don't believe it, that's not enough, because cryptography expert will tell you that any encryption that you use today, they will break it in 10 years from now. So if it's on a ledger that's accessible, in 10 years they will access the information that's in it if they want to. So the golden rule when it comes to privacy is, if you want to keep something private, you do not share it in any shape or form. The beauty of the system that I just described is that personal information is not stored on the ledger at all. Not even a hash, because a lot of people try to work around the GDPR by saying, oh, I'm going to hash the information. And, the jury is out as to whether it is considered personal data or not. But the academic people will tell you hash of personal data is personal data. And the rationale is, well, If you ever got access to the personal data, you could find the hash again, and you could put the two together. That's correlation. Therefore, there is personal data. And the same has been said for public keys, which clearly, pushes the envelope a little bit. But, and the study group that I was part of basically concluded that's just the way it is. And in fact, it's the court. The legal court will eventually decide what is personal data or not when there's a lawsuit. In the meantime, we have to be careful. And so, in any case, the system I described only stores public keys of the issuer, which typically is an organization like the university, your employer, the bank. None of these people are persons, and therefore GDPR does not apply to them. The credentials that is personal is actually held directly by the person in their digital wallet. And by the way, when I said digital wallet, you should not think that this is a one thing where I have everything. Because if you think today, your identity, you have many different credentials, and I'm sure you have in your pocket or your purse a wallet which has a bunch of credentials, credit cards and IDs, driver's license. But not all your IDs are there, right? You have some that are left at home, probably. So in a similar way, we may very well end up with many different digital wallets, and that store different aspects. So what's on the ledger is decentralized IDs, public keys. There's also service endpoints, and that kind of information, like I talked about earlier, schema information. These are all information that will be used for the system to be able to talk to one another, and because basically when you do zero knowledge proof, this is a dynamic process, there's a protocol, and so the information will point to a service where you can actually do the zero knowledge proof. All of this needs to be open, and I said that in the goal initially, right? In the ideal scenario, we would have interoperability and portability. The good news is there's a lot of work underway to make all of these standards-based, because at the end of the day, this is not going to scale and be broadly adopted if it's proprietary-based. And everybody understands that, because if I go to my bank, they issue a credential in some format, and then university gives it in another format, etc. It's not going to work. We need to decide to agree on, what the format of the data is, and how I communicate that information, both from the issuer and also when I talk to a verifier, somebody who's going to want to verify my credentials. So there is different standards activities going on. I'm not going to get into the detail. The main one is the decentralized identity. A couple of them are actually happening within the R3C, but there are others. DKMS probably will end up at Oasis, and because there's a whole notion of, management of your keys. And it was said earlier today, if you lose your keys, you're kind of in trouble. So with more power comes more responsibility. And so we're going to have, for this to really succeed and get broad adoption, we are going to have to make it easy for people to use those keys, gather those credentials, and not lose them, and possibly recover them when they need to, right? In fact, if you think about the way it works today, if your wallet gets stolen today, I don't wish it, you can still recover, right? There are ways you can go and you can say, okay, this is who I am, and they will verify your identity in some way, and they will reissue, your credit cards will be canceled, and so on, but you can recover. And so people are talking about replicating all these mechanisms in a very similar way. And, but all of this, again, is going to require a lot of standards. So there are different organizations that are working on this, as well as on an open source front. I talk about Hyperledger Indy. There's another component, the DeFi Foundation is also working on the DEED part. And the idea is that, I said the credential, the keys, or the cryptographic material, more generally speaking, is stored on the ledger. There isn't going to be a single ledger where all the keys from all the world is going to go, right? In fact, there already are several systems in place today that exist I mentioned Sovrin in my slides. There's another system called Uport, which is related to Ethereum. There is actually a method also where they use Bitcoin as the backend for the storage of the credentials. There is one called VerisOne, which uses its own network, and there'll probably be others. The key is that this decentralized ID, this is the pointer that's in your credential that's given by the issuer. When the issuer puts it on the chain, they actually have a pointer to it through the DIT. And it's a URI type of thing, so it works across the different systems. So I'm running out of time. I'm going to end here. Thank you very much. It's a bit quick, but...